Cadets, welcome to the MMA Pythagoras. Our mission today is to track down and capture the freighter Da Vinci, which is suspected of smuggling calculators out of the country. The freighter Da Vinci left this morning out of port at around 1100 hours and was reported going south at 30 knots. It is now 1300 hours and we're pulling out of port at 60 knots. In order to coordinate the capture of the Da Vinci, we need to know how long will it take us to overtake the Da Vinci. And that's why now, our mission is requiring us to catch up and overtake the Da Vinci so that we can stop them. Well, it needs to be a coordinated effort between us and other units, so we really need to know how long will it be before we overtake the Da Vinci, and that's where math comes in. And what we need to do is look at first what formula, if we have one, that we can use. Well, for what we're doing, it deals in distances, it deals in rates, and deals in time. So let's use distance equals rate times time. So let's go to the Googleplexer and see what we can do mathematically. So first, the formula that we want to use is D equals RT. Now, I like to work with it in a table, which really I'm just going to change this formula around. I'm just going to say RT is equal to D. It still means exactly the same thing. So now if we go to the table, we start out with a column right here. I like to call this my description column, so I know kind of what I'm talking about. And we're going to have two columns here. We're going to have the Da Vinci and we're going to have the Pythagoras. So we'll do D and P for those. Now the first column is rate, because we have rate times time is equal to distance. So we're going to first fill in what do we know about the rates. Well, we know that the Da Vinci is traveling at about 30 knots. We know the Pythagorean can travel at 60 knots. Now next we have rate times time. So the next column we want is time. Now here, we don't know how long we're going to be as far as until we overtake them. We're not interested in when did we leave, but how long are we into this trip. So this is where we don't know what they are. So this is where we assign variables like X, how long will the Da Vinci have traveled? Y is how long has the Pythagoras traveled? Now if we take and we multiply those now together, then we have rate times time is equal to distance. So now I have 30 times x, which is 30x. And I have 60 times y, which is 60y. That represents how far each of the ships will have traveled. Well, in order for the Pythagoras to overtake the Da Vinci, we both left from the same port, then they have to have traveled the same distance. So setting up our equations, we would have 30x, the distance of the Da Vinci, is equal to 60y, the distance of the Pythagoras. Now the other thing that we do know, now this is where the times when we leave takes somewhat of an effect. We know that the Da Vinci left 2 hours before we did. So if I'm looking at these times right now, I know that the Da Vinci, the x, is going to be 2 hours greater than the y. So we need to, in order to make them equal, we need to add 2 hours to our time so that both of us have the same time as far as the equation goes. So there's my two equations I need to solve this problem. We have a system of equations. Now for this one, I would really like to use the matrices to help us solve this. So to develop the matrices, we have to first have our equations in standard form. So we're going to take and put this in standard form. Means all the variables need to be to the left, or one side or the other, but to the left usually is where we go. To the left of the equal sign, all the constants need to be to the right. So to get all the variables to the left on this one, I need to subtract 60y from both sides. So I've got 30x minus 60y is equal to 60y minus 60y is 0. So now all my variables are on the left, my constant is on the right. We need to do the same thing with this second equation also. So I'm going to subtract y on this one. So I'm going to have x minus y from this side. And then if I subtract y from the other side, then the y's cancel out and I end up with just 2 left. So here's my system of equations. I have 30x minus 60y is equal to 0. And I have x minus y is equal to 2. There's our two equations that we can start with. Now I wanted to use matrices. To do the matrices, to make a matrix first we look at just the coefficients. The coefficients are the numbers that are in front of our letters. So if we look at the first equation, then what are the numbers that are in front of the letters? So right here we've got 30. So we want to put a 30 in row 1, column 1. Then right here we have negative 60. So we want to put in a negative 60 in row 1, column 2. And then we go down to row 2. And what do we have right here? Not 0, but 1. It has to be 1 times x. If it was 0, we would have no x that would even be there, because 0 times anything is 0. So my coefficient there is 1. And the coefficient here for the y is negative 1. So we have negative 1. Now we need an augmented matrix. This right now is just the coefficient matrix. So we need the augmented. We need the answer part to go along with all our coefficients. So we need to add in the answers 0 and 2 that everything is equal to. And now we have the matrix that we can use to help us solve how long will it take us to catch up to the Da Vinci. So let's start out now with that matrix. So we'll begin with 30, negative 60, and 0, and 1, negative 1, and 2. Now, if you've been following along with Math Matters Academy, you know that in one of the previous videos that we had, we did an introduction to matrices, and there are only 3 operations that we can use to work with matrices. And one of them is we can rearrange or change the rows. So I want to, first off, I need to have 1 up in this row 1 and column 1. So an easy way to do that is just get this one down here up there by just simply changing these 2 rows around. So I'm going to rearrange this matrix by moving row 1 and row 2. I'm going to change their places. And we still have an equivalent matrix. It's just like, oh, I put one equation on the top and the other one on the bottom. That's all we're doing. We didn't change anything. So here's our new matrix. It's equivalent to the first one because we followed one of the 3 rules that we can use for doing matrices. Now, when we are trying to play the game of matrices, we want this to be a 1, and now we want this one down here to be a 0. That's the next one we go after. So how do I get 30 to be a 0? Well, in order to make it go to 0, you have to either add or subtract. So what we're going to do, one of the other rules that we were allowed to do with matrices is we can multiply a row. We can also add or subtract a row. That's actually 2 rules. We're going to put them together. So now we're going to take row 2, and we are going to subtract 30 times row 1. So row 1 doesn't change. We got it right where we want it. So let's write this down real quick. Okay? We don't want to change that. But now, go to row 2. First off, this is the way I like to do it. We're going to take row 2, and we're going to subtract 30 times row 1. So do this first, right here. 30 times 1 is 30. Now take this 30, subtract that 30, and what do we get? 30 minus 30 is 0, just what we wanted. So now let's do it with this one right here. Times this by 30. Or negative, actually, well, no, let's do 30 first. 30 times negative 1 is negative 30, but because we're subtracting a negative is the same thing as adding. Two negatives make a positive. So now that's positive 30. Add that to negative 60, and we end up with negative 30. Okay? Take negative 60 minus 30 times row 1. Negative 60 minus negative 30 is negative 60 plus 30. Okay, that's how I got negative 30. Now let's go to the final one here, the 0. Well, first multiply the 2 by negative 30. We get negative 60. Negative 60 plus the 0 is negative 60. So there we have an equivalent matrix, and we're getting closer to where we want to be. We still got to keep moving, because this right here now, this negative 30, we need this to be 1. Anytime that we want an entry to be 1, the best way to get there is to divide, because if you divide by whatever the number is, you end up with 1. So that's kind of the key thing to be looking for here. So we take the matrix that we ended with. We want to take now row 2 divided by negative 30. Anything divided by itself is 1. Row 1 we're not going to touch again. We already got that the way we want it to be. So there that is. Now, row 2, we're going to take row 2 and divide by negative 30. So first, take 0 right here and divide that by negative 30. Well, 0 divided by negative 30 still is 0. Take now negative 30 right here and divide that by negative 30. Negative by negative, positive. 30 divided by 30 is 1. And now, finally, negative 60 divided by negative 30. Negative divided by negative is positive. And 60 divided by 30 is 2. Okay, so now typically this is where a lot of math books stop. They just kind of stop you right here and then you back substitute. Well, I want to take you on to the next step, in that I want to take you not just through the row echelon form, which this is called rref, row echelon form. I want to take you to the reduced row echelon form, because then it gives us our answers right out of the matrix. So what do I have to do now? Well, we need to get now this negative 1 to be a 0. That's all we got left to do. Get this to be a 0. How do we get something to be a 0? Either add or subtract. Well, what if I took row 1 now and just simply added row 2 to it, and that would make it 1 negative 1 would be 0. So we're going to take row 1, add row 2, and replace it in row 1. So here we go. Row 2 now is done. We're modifying row 1 just a little bit. We're going to say, well, first off, row 1, let's see. We've got 1 plus 0. That still is 1. Then we got negative 1 right here, and 1. That is now 0. But don't forget this one. 2 plus 2 is 4. And now we're in reduced row echelon form, rref. Final out of all of this is x equals 4 from that row, and this row, y is equal to 2. So now we know what the times are for both of our ships. So if we go and kind of like move this up, if we left, whoops, too far. If we left at 1300 hours and our time was this 2 right here, so we add 200 to it, then we are going to catch the Da Vinci at 1500 hours. And if you look at now the Da Vinci left at 1100 hours. And their time now is this one right here is x equals 4, so we're going to add 400 hours. And so 11 and 400, 1500 hours, we both will, we will overtake them at exactly the same time, at 1500 hours, at 3 o'clock in the afternoon. Now, because this is a story problem, we really should have a story answer, and we could have something like Pythagoras will overtake the Da Vinci at 1500 hours. And that's why math matters. Hi, cadets. This is Math Master Mike, and I just want to thank you for watching the video today. If you like what you saw, hit that subscribe button down below. Otherwise, we'll see you next time on the Pythagoras as we encounter another challenging Math Matters.